Okay. Thanks again, everyone, for coming out. So this is a increasingly broad and deep subject at the same time. So we will try and cover some things that will provide you with some perspective on both the breadth and the depth, but certainly a conversation that we could dive into at any point to a significantly deeper level of depth. Thanks again, Daniel, my client, for hosting this tonight. Fantastic. So let's talk a little bit about what we're going to try and accomplish tonight. First, are any soccer fans in the house that want to give me like a real quality Brazilian goal? Cheer. Anyone brave enough?
Some Brazilians here.
No? Okay. I'm not going to do it, but I thought one of you might do it. So what I want to accomplish today is a couple things. Some people more familiar, some people less familiar. So we'll just spend a couple minutes talking about what our perspective on serverless is, a little bit of groundwork, a little bit of homework. Then spend some time talking about the common patterns that we see customers be successful with. So what does this look like? How should you be reasoning about your architecture and serverless perspective, and what are some of the types of workloads that fit well for this pattern today? So it's sort of expanded in scope over the last couple of years. So we'll look at the canonical architectures for different use cases, and then we'll talk about best practices. So the best practices are going to cover a bunch of different areas. We'll talk a little bit about testing and DevOps. We'll talk a little bit about performance, and we'll talk a little bit about security as well. So what I hope that you guys get out of this today is that you learn a couple things you didn't know before you came in any of those subject areas, but also that you are inspired to build workloads in a serverless fashion. There are maybe workloads you didn't realize could be built that way before, or were good candidates for that type of thing. So, so that being said, a little bit more about me. So I work for AWS Canada. I'm a startup solutions architect. What does that mean? So I work both with our startup customers across Canada and also with the ecosystem. So accelerators, incubators, VCs, innovation centers, that type of stuff, and help the companies that are in their programs align to best practices when they're building in the cloud, on AWS, and anywhere else really for that matter. So we're very customer focused, and serverless is one of those things that we introduce to them very early. Sometimes it's a good fit, sometimes it's not, but it's definitely something we want to make all of them aware of right at the beginning because of the properties that you get out of building that way, right? So agility, speed to market, flexibility, that type of stuff. So we'll dive into that a little bit more. I've been using Lambda personally since it came out in 2014. I have done some unspeakable things with it in that period of time. Learned a lot of lessons the hard way myself. So some of these things are internalized. What else about me? I used to do a lot of development. I've written a lot of PHP code, probably more bad PHP code than all of you combined. I've written PHP in Lambda, which is fun too. So if you guys haven't seen custom runtimes, the ability to now bring your own runtime environment to Lambda, that's something to check out. So you can write PHP in a serverless fashion if you so choose. Don't do that, but you can. What else? Non-technical information or non-job information about me. I like to share with people that I've personally scored a goal at the Scotiabank Arena back when it was called the Air Canada Centre. Yes, it was pickup hockey, but that was still possibly one of the highlights of my life to this point. So anyway, enough about me. Let's get into the serverless stuff. So as I mentioned, some people here have more experience than others. So let's talk a little bit quickly about what serverless means to us, right? How many people? I heard some of you talking about it. Just quickly by show of hands, how many people are running serverless applications in production today? Awesome. Okay, very cool. Like almost half of you. That's amazing. So, quick refresher then. What does serverless mean to us? Right? So, when we talk about serverless, we are talking about a lack of infrastructure management responsibility on your part, focusing on the business logic. So, not patching, not scaling, that type of stuff. It means that your application is dynamic based on requirements. So, as more users arrive, you are provisioning more capacity. As users go away, that capacity is turned down in a much more granular fashion than you're used to with something like auto-scaling in virtual machines, where you have a very blocky scaling function. With serverless, we look for nice, smooth, scaling function with demand. It means that when your application is not being used, you're not paying for it. Awesome for development and test environments. Also awesome for production. Also awesome for startups, right? So not starting to spend on infrastructure costs when you don't have any customers is a really nice position to be in. And lastly, you get all the benefits of what we would normally consider to be cloud native built in. So when you use a service like Lambda, for example, you are gaining regional high availability, you're gaining scalability, you're gaining fault tolerance, you're gaining security. All these things come baked into the service so that you do not have to do that IT busy work, right? Okay, so that is serverless. The boundary is a little bit fuzzy, I think, sometimes, because to me, Fargate, if you're familiar with Fargate, quickly put up your hand as well. Okay, less people. So Fargate is a container orchestration service that we offer where you do nothing but provide us with the container details, right? So you don't stand up any VMs, you don't have to manage that type of hardware orchestration. All you do is define your container spec and we run it for you. So, Fargate will not scale completely to zero, but I still consider Fargate to effectively be one of our serverless services. So, it's a little bit fuzzy sometimes. So these are the core tenets that we work with. A couple things to know. If you find something that we talk about here insightful, or if you just want to start a Twitter fight over something gigantic, happy to engage in both of those things. ServerlessTO is a hashtag. You can find me at Apted. So before we dive into some of the patterns, let's talk a little bit more just about the operational model and get out of just the compute mindset, right? So serverless applies to a broad range of things. Can anyone tell me in one sentence what AWS means when we say the shared responsibility model? Not you. Anyone? No? Okay. So the shared responsibility model means that we are in a partnership with our customers in accomplishing their goals, right? And we used to talk about it almost exclusively in a security context, but it now applies really across the entire operational context of workloads that run in AWS. So if you look at this chart sort of from left to right, the boundary of the shared responsibility, like where our responsibility starts and stops and where the customer's responsibility starts and stops, sort of shifts as you move from left to right, right? More customer on the left, more us on the right. So obviously in compute, you go from virtual machines through sort of PaaS type services to Fargate, which I just talked about, to Lambda, which you're probably most familiar with. Like Lambda and serverless are somewhat synonymous. But this applies to a whole bunch of other different types of services as well. So, to choose database as an example, you can have the flexibility and the customization and all the operational overhead of running a database on EC2 by yourself in a virtual machine. You can choose something like RDS, where we provide a bunch of management tools for you to make life easier, but you're still thinking in the construct of instances. Or you can go to something like RDS Aurora, where now we are taking care of highly available storage engines for you as well. Or you can think about something like Aurora Serverless or DynamoDB now, where really all you're doing is defining, even at a very loose level with Dynamo, your table schema. You're putting data into that table, and you're turning knobs in the service to get the QoS that you expect, and that's the end of the management obligation for you. So don't just think of serverless as compute. We'll refer to a bunch of these different services and some of the architectures today. Really think of it as that operational model where we are pushing that boundary of shared responsibility, both in security and operations and everything else, as far to our side as possible. Hold on a second. I'm back. There we go. So these are some of the services that we'll touch on today, right? Obviously, Lambda is sort of at the core of all this. But on the compute side, we have Lambda and Fargate. Data stores, things like S3 for actual object storage, or serverless and DynamoDB, relational, non-relational, data persistence options. And then some of the other tools that go with those in the portfolio, Amazon API Gateway, some messaging services, and some orchestration services and deployment services. So these are all things that come into the puzzle when you're talking about working with serverless constructs and serverless workloads. let's get into some of the patterns, right? So I want this to be a little bit of a progression. We'll start with some of the simpler patterns, some of the ones you're probably a little bit more familiar with, and then we'll look at how those get extended, and also some of the other ones that maybe you don't traditionally think of when you consider serverless. So think about through this whole thing, that abstraction of the IT busy work, right, out of what your job is, focusing purely on the business value or the workload value that you're trying to accomplish. So this is going to look familiar, I hope, to everybody, right? So we have our classic, N-tier web application. Normally this would be Nginx at the front, some sort of application server, Express, PHP, something in the middle, and then a database at the back end. So very, very classic architecture. So we can take this to the serverless world by subbing in these different services. So Amazon API Gateway at the front, this gives you your routing, right? Your REST endpoint for everything that comes behind it. Lambda in the middle for your logic, business logic, and DynamoDB at the back end, which gives you consistent millisecond access to your data. The other things that come for free in this, right? You get things like rate limiting, API keys, throttling, really, really flexible Swagger type definitions at the API level, flexible sizing for Lambda functions. So this is very, very simple on its surface. This is very, very easy to stand up. This is something that comes up in a minute you can start working with. So different knobs to tune as you start getting more familiar with the different services in it. But if you're building a web application, this is your core pattern, right? Everything starts with this. So you can shove an entire Express application into a Lambda function if you want to. Probably, not the best idea. It's a starting point, but as you start to evolve from a 3-tier web app where you just replace the servers, the proxy, and the database with something like this, you start moving towards, if you don't want to wrap your head around NoSQL right out of the gate, then consider Aurora Serverless as well for relational. So that's another option.
I have a question.
Yep.
So this is web application architecture, but we didn't show S3 for the front end.
Yeah, so in this case, I'm even just considering maybe you're using a template engine and you're serving the entire thing directly out of Lambda here, right? So not even moving towards a single page app. This is an entire web application wrapped up as you would traditionally deploy it in a virtual machine inside of serverless. So that is something you can do, right? If you so choose.
JavaScript is basically rendered from Lambda to your browser.
Yeah, exactly. Yeah. So the next sort of evolution of this would be to treat this strictly as an API, right? And then to take your single page app, React, Vue, Angular, put that in S3 as your front end, and then this becomes strictly your back end.
One more question.
Yep.
If that's the case, in my JavaScript storage, how do you protect API gateway? Let's say I have a publicly facing web app.
Yep.
Deployed on S3 and exposed some data.
Sure.
So that would be completely available.
So the question is, how do you protect your API if this is a pure API? So we have a service called Cognito. Cognito manages authentication. It can store the users directly in a user pool itself, or it can federate to an external source of identity, social identities like Facebook or Twitter, that sort of thing, Google. So your users, as they're coming into their application, right? If you want your calls to your API to be authorized, you have some sort of identity store, whether it's Cognito or otherwise. And the API gateway has an authorizer function on it, and you're checking the validity of the token that the user is passing to the API, and then either accepting or parameterizing what they can do with that request. Does that make sense?
If it is publicly facing website and people enter server information, and this API should be only called by my app, which is on S3.
Yeah.
How can you protect it? Do you still use Cognito, or can you do any other kind of mechanism?
So it's still the user calling the API, typically at the end of the day, right? So in a single page app, the user is making API requests that are now populating the front end of the application. So all you're doing to protect it at that point is authorizing the requests, and you're determining what routes in the API and what data that lies behind that API is accessible to that user based on who they are. Or if they're anonymous, what information is available to an anonymous user. And we can dive into this afterwards. We can talk more about it and draw some stuff out together. Okay, so we started with our simple web application. So as you get more comfortable with this, as you start to gain some operational sophistication, you may go beyond that single application, and you may start to venture into microservices, right? Or what looks a little bit like microservices. So you still have that same entry point for your application, but now you're starting to divide out your concerns into multiple functions. So rather than having everything in your application shoved into one Lambda function like you would have done in the past when you're deploying an application to a VM, you're starting to parcel things out. So if you have, let's say, a shopping cart on your site, right? The /cart URL from API Gateway goes to a specific Lambda function that is responsible for serving the logic for that. That specific Lambda function has its own data persistence, right? So you can choose what data persistence layer is appropriate for that microservice. And it's kind of hard to see because there's a plant in the way, but the top microservice here is using DynamoDB, the bottom one is using Aurora Serverless. So you can start fracturing your application into those smaller units of concern, which then give you the ability to iterate those separately, right? To operate on those separately. They'll scale separately. In this case, scaling is not something you have to be super concerned about, but if you're paying really, really close attention to how you want your concurrency of your Lambda functions to run, you have the ability to fine-tune them on a per service basis here. So you can define the ones that are critical, the ones that are less critical, and sort of do your own QoS in terms of how you want to manage scaling inside the application. So you can start going out laterally in your application at the compute and data layer while still bringing all your traffic in through that same API gateway. So an important question then becomes, do all my microservices need to be publicly available? Right? And this might go a little bit to your question as well. So does this pattern just continue downwards forever? Typically inside of an application, a lot of the services are internal supporting services, right? They don't actually need to be exposed to users. We sort of refer to this pattern at this point as like a microservices iceberg. So you have a couple services that are floating at the top that are accessible to the public, and then the rest of the services actually just support those front-end services. So they're not actually exposed to the public. So do those services need like a API contract, like a REST endpoint? Possibly not, right? So this is where we start seeing some of those messaging patterns that we mentioned right up at the front. You saw SNS and SQS and things like that. So let's talk a little bit about that. First, how can you invoke one microservice from another, right? What are some of your options? Let's talk about those first. Your first option is literally to use the Lambda API, right? So from within one Lambda function, you can call another Lambda function using the AWS SDK. So you don't have to go through a REST endpoint, you can just invoke the function directly. You can do it synchronously, you can do it asynchronously, you can pass along whatever portion of the payload you need to, right? The AWS SDK is included in the environment for Lambda, so you don't even need to bundle any dependencies into it. This is available to you right out of the box. Now that I've told you about it, I'm going to suggest that you don't do it. So this is certainly an option, and it's something you can use at the beginning to get started. But I wouldn't consider this to be anywhere close to best practice, especially given all the other options that are available. Because if you do it this way, you are now responsible for all the retry logic, all the error handling, all those other types of things that need to take place, right? So be aware that this is possible, but treat it as a last resort. So these are the other different ways that you can invoke a Lambda function in a microservice environment. We've talked about API Gateway at the front, right? So that's your sort of classic web application. And that is generally a synchronous operation, right? A user is making a request, they expect something back right away. So what are your other options? We have event-based invocation. So Amazon SNS, objects landing in S3 might be an event. Those can all trigger Lambdas. Most importantly in our microservice server model here is SNS. And then there's stream-based options. Right? So both DynamoDB, which will emit streams as you change things in records inside of Dynamo, NoSQL database, or you can place objects directly into Kinesis data streams. And those streams will also be used as an invocation source for Lambda. So let's look at a couple of those in more detail. So SNS, so if you think sort of event bus, right? Go back to the event bus model. Now you're inside your application. You have a microservice that's going to emit an event. Something has happened that other services are going to want to know about. And you have one or more of the other microservices subscribing to the topic and receiving those messages. You can do things like filtering those messages to minimize the amount of sort of switch logic that you have to build into the front of those functions to determine whether that message is relevant to them or not. But this is a really nice, simple pattern. SNS is a fully managed service, effectively unlimited scale and throughput. So you don't really have to worry too much about the service itself. Something to consider in this model, though, is that it doesn't really give a ton of consideration to the downstream services. Right? So SNS will be more than happy to keep up with as many messages as you want to put in there. You have to think about the capabilities of the services downstream that are going to be consuming those. So this will work in a lot of different environments. But if you're starting to think about the sensitivity of the downstream services, then one of the sort of sister services of SNS might be something to consider, and that's SQS. So rather than it strictly being an event pipeline, you're using a queue type model. So this was one service that was not on that initial summary screen. It's a little bit interesting, right? Because it doesn't quite fit into the event-based model. It's a little bit more of a polling type model, but at the same time, it's like not quite the same as a data stream, different properties to it. So it sort of stands alone. But effectively, what you're doing here is decoupling the capacity of the generating service from the consuming service. So anywhere that you don't need real-time or synchronous response, you can use an SQS queue to decouple the capabilities of those two different services. So a consumer can either scale at its own rate, or if you don't really care about the immediacy of that message, it can sort of consume a spiky queue just over a linear period of time, and in your downtime, in your slower periods, it will catch up. All these things are certainly things that you can monitor, right? So we'll talk about observability a little bit later on. So you can pay very close attention to whether your functions are keeping up with your queues, or whether if you're using SNS, you're overwhelming your downstream functions. But these are two choices to make sort of from a messaging perspective. Either a fan-out model through SNS, or a queue-based model where the consuming service is pulling that queue, taking messages off in batches and processing them. Something to point out here that is actually important. At least once discovery is on the delivery, is on the slide. So another thing to remember when you're building in Lambda or in Serverless is that whether you want to or not at this point, you're now building distributed systems. Right? So there are going to be properties of distributed systems that you need to be aware of and that you need to respect. That means that because you're leveraging both a delivery service and a compute service here that are fully managed for you, but managed across a massive distributed architecture, it is completely plausible that occasionally a message will be delivered more than once. Yes?
Is it possible to reach the exactly once delivery?
Sorry?
Exactly once delivery.
Yeah, so you can use a FIFO queue, and that will help guarantee single delivery, but the throughput capabilities of the FIFO queue are significantly lower than a standard queue. So really the strong use cases for FIFO are a little bit narrow. Usually the best choice is SQS, and just being conscious of the fact that your consuming service should be, and this is a word I can never pronounce correctly, but idempotent, to the level that is required by your business function, right? So if it's something you absolutely cannot process twice, you should be checking to see whether you processed it already and throwing those away if they're a duplicate. If it is idempotent, then you can just go ahead and process it again the second time and it won't matter. Yes?
Regarding this seven pattern, there's a difference between the two. Lambda is function, number two, Lambda function is involved. Is involved after the message is being posted. So if each time the message is posted, and Lambda is involved, what's the difference in the SMS? Message is being posted, Lambda is being involved.
Okay, so the question was, what is the sort of invocation difference between the two? If you're posting a message, does it immediately invoke the function? So with SNS, those messages are being sort of pumped out on an individual basis, right? With SQS, the service is pulling the SQS queue for you. It's pulling the messages down in batches. The service will scale the concurrency of the Lambda function for you as the queue depth increases. And then you're taking those messages off sort of in chunks, right? So it's not and it's not a immediate reaction to every single message. It's a reaction sort of generally to the depth of the queue, and you're still pulling those messages down in batches, as opposed to an SNS where you're receiving events one at a time. You have a question?
I just want to ask about the downside of the type of queue. Is that just the throughput, or is there anything else?
Yeah, pretty much. Yeah. Yeah, significantly, different, like order of magnitude different. So 300 per second versus unlimited.
So it is possible when we don't have a lot of traffic to start with FIFO and then add more logic to make it idempotent once we have more traffic?
Yeah, I mean, that's so the question was, can we start with FIFO and then, invest in idempotency? It's getting easier every time I say it. Invest in idempotency as we go forward. Absolutely, you could do that. I mean, I think anytime we promise ourselves we'll do something later, that's a risk, right? So maybe think about the level of effort up front in both those cases and make an appropriate decision. All right, so those are the two sort of key internal messaging options that you have for your microservices. So let's get away from our sort of standard web application microservice for a second and talk about some of the other patterns that we see people using serverless for and some of the other serverless processes or services, I should say. So the first one I wanted to talk about is essentially stream ingestion, right? So classic use cases for this might be clickstream data coming in off your website, could be IoT data coming in from sensors in the field, could be real-time data feeds, could be social media polling. There's all sorts of different potential cases where you're going to be placing data into a stream and then consuming it. And so the sort of core service here to think about on the ingestion side is Amazon Kinesis Firehose. Firehose is a fully managed stream service, think Kafka basically type service, ordered persistent data storage for a period of time that you define. It gives you the ability to consume that stream from multiple consumers. So you can have a variety of different applications that may want to access that data. In the case of Firehose, we are taking that data and delivering it to a destination on your behalf. So you don't have to write a consumer here. You just have to tell us where you want that data to go, and we will put it there for you. So your options that you can see, again, sort of competing with the plant, down at the bottom right. Amazon S3 is sort of the most common one, right? So you're writing those records down to objects in S3 for durable storage, and then you're going to potentially do something with those objects, analytics, machine learning, any of those things down the road. Elasticsearch is another option. So if you're taking sort of log data or something like that you want to have really complex search capability in, maybe you're taking event logs into storage and you want to be able to search through them sort of SIM style. Elasticsearch would be your option there. And then lastly, you can load them into a data warehouse like Redshift. So where does serverless fit into this? Think of Firehose as kind of a serverless service because we manage everything about it for you, basically, right? Like you don't have to scale it, you don't have to feed and water it, you don't have to patch it. We take care of that for you. And then there's also the ability to operate on the records in Firehose as they go through. So if you need to do any sort of data transformation, then we get back to using Lambda again. So this is another use case for Lambda, operating on the records that are in your Firehose stream before they land in their persistent storage. Why would we do this? One of the core tenets of building a data ingestion platform is try and minimize the amount of responsibility you place on your producers, right? So the flexibility of producers becomes really, really important over time, especially from like a data lake architecture perspective. So the less structure you enforce on your producers, the more producers you can have. If you need to do things like change your records format, say from CSV to JSON or JSON to something else, or put it into a compressed format like Parquet, you can do that in flight with either Firehose or with Lambda as your transformation function. Okay? So maybe transformation is not enough. Maybe you want to enhance those records as they're coming in. Then we bring back in another one of our services that we talked about earlier here, Dynamo. So you can leverage Dynamo as that metadata store or that enrichment record store that you're going to reach back to with your Lambda function and enrich the records coming in. Potential use cases here might be enriching like geolocation data or something like that, right? So there's something small, like a marker basically coming in with your record as you're ingesting it. You want to go out and get more metadata about that record and add it before it gets persisted to S3 or to your data warehouse. You can use a combination of Lambda and Dynamo to do that while still ensuring you have that really, really low millisecond latency access to your enrichment data in Dynamo. Does that make sense? So, did I do that? No, okay. One other thing to consider here, really nice pattern for, again, spiky workloads, right? So you start thinking, well, consistent in-down streaming data, this is starting to sound like something that I should just spin up a VM for because it's going to be running all the time. IoT sensors like thermometers or thermostats, right? Everybody comes home at 5 o'clock and changes the thermostat at the same time. So all the things that we're used to in the web application side of architecture, right? The ability to scale up and back down again really quickly applies in this case if you have spiky ingest on your in-down streaming data. Something else to talk about on the streaming side here is potential fan out again, right? So now we're going to move from Firehose to the pure data streams functioning Kinesis. A little bit different in the sense that now we're responsible for consuming those records ourselves, but we can again use Lambda to do the consumption, to take that data and do something with it. If we want to manage the sort of throughput requirements on the data stream itself, we can then start building a fan-out pattern in Lambda as well. We can have a dispatcher function that is responsible for reading the stream and marshaling that data out to downstream services, or going back to our messaging principles, possibly either posting to a topic or dropping data into a queue based on what it is. So you can start mixing and matching these things together to accomplish what you need to do. Just think about the sort of the characteristics and the behaviors that you need at each layer as you're choosing the service. All right, one more streaming opportunity for you here. Add in the last service from Kinesis, which is real-time data analytics. So this one's kind of cool. So you're bringing in data via Kinesis data streams, right? So you're ingesting data. You can build what we call a Kinesis data analytics application. What that allows you to do is to effectively define through SQL statements some sort of operation that you would like to make over that data as it comes in. You can do that either on a rolling or sliding window basis. And then you can take the output of those SQL queries and either send them to their own data stream, right, for whatever is going to happen to them, or you can invoke a Lambda function and pass the results to that. So thinking of an example use case here, let's say you are streaming clicks data through your website, right? So you know a user is on your website, they're moving around, they engage in a particular type of behavior, pattern of clicks over the last 30 seconds that you recognize means they're maybe going to buy something, but probably not. You can then immediately respond to that behavior by sending them a push notification or an email or some sort of message with a little bit more of an offer to entice them to take that last step and buy. Maybe in a security context, and where a lot of Trend Micro ends up here today. As you're streaming, event data about what users are doing in your system, and you can start looking for particular patterns on a window basis that indicate bad behavior, and then take remediative action about that behavior through a Lambda function right away. And so it gives you the ability to respond in real time to data as you're collecting it and persisting it for future long-term analytics capability.
How big is the sliding window?
You set the sliding window in either seconds or I think minutes. Do you know what the biggest sliding window is? Now, I'd have to look up what the maximum sliding window is, but that would be a to the docs kind of question. We can check it out afterwards.
Thanks.
Okay, so away from streaming, one more sort of interesting serverless architecture. Effectively, batch processing or MapReduce of inbound data, right? So you start with something like S3, so object storage. As you have your objects landing in S3, you have a Lambda function that responds to that event. If you remember back at our different models, the sort of middle category was event-driven, right? SNS. S3 objects appearing in storage. So you can pick up that large object. You can use that initial Lambda to break it apart. You can pass all those files to their own Lambda processing function, right? The Functions will then take the output and write them into a DynamoDB table. And then a reducer function at the end will take all those entries out of the DynamoDB table, combine them together, and persist that output either back into S3 again, possibly into DynamoDB, somewhere like that, right? So your classic sort of Hadoop style MapReduce pattern can also be run completely serverlessly as well. Again, benefits being flexible variable workloads, scaling on demand, no servers to feed and water, no HDFS to maintain, that type of stuff. So this extends well beyond your typical sort of application, microservice, streaming data ingest to even some extremely traditional workloads like MapReduce. So one more layer of complexity to add to this. Everything that I've showed you so far has been pretty simple, right? So we've been using like one or two services in combination with each other. That's going to be your starting point always, right? Like start simple, understand how things work, start to scale them out from there. If you start getting into more complex workflows where you're involving other services or you're starting to see a need to tightly couple the outputs and inputs of different Lambda functions together, something to think about is the step function service. So step functions is essentially workflow management. When it initially launched, it was very Lambda focused, Lambda only, basically. It gives you the ability to start thinking in terms of like parallelism, loops, conditionals as you're building workflows with Lambda. Right? So we talked a little bit earlier about not wanting to invoke Lambdas directly from each other because you have to manage retries and error handling and all that sort of stuff. This is exactly built to solve those types of problems. So abstracting all that orchestration work out of your business logic and into a managing service. The step function service has evolved very rapidly since it was released. And one of the cool things about it now is that rather than being strictly a means of orchestrating a bunch of Lambda functions together, it now has direct service integration with a bunch of the different services in AWS. So if you look at the pattern on the left, where you are submitting a job, we have a wait function, we're going out to get a job status. Is the job complete? No. Okay, then we'll wait a certain period of time, we'll check again, is the job complete? The three submit job, get job, and pass a message to SNS boxes there are actually Lambda functions. And so we had to write glue logic to basically move data from one service to another. Today with direct service integration, the workflow would look something like this. So you can specify that you want to synchronously wait for a job to complete, you want to take the output of that job, and you want to do something with it based on the condition that you get back from it. So the actual sort of complexity of the models that you can build with step functions today are much simpler. They're basically defined in JSON, I believe. So there's some tooling out there to help you write them. Writing the raw JSON can be a little bit overwhelming as the complexity of your step function increases. But take a look at this if this is something that you feel might be helpful to you in terms of orchestrating a bunch of services together in a workflow that is meant to be, sort of dependent on each other and the outcomes of the steps before it all the way through. Okay. Any questions? Let's pause for a second. Any questions specifically about the actual architectural patterns? Yeah.
Pretty much on your last slide there, where I guess you had several steps. I assume it's possible to throw all of that logic into a single Lambda function, and so that's why I'm curious. Like, at what point do you decide there's enough code for a Lambda function versus I should break this up into like 10 different steps or 5 steps?
Right. Okay. I mean. The standard engineering answer, it depends, applies here. But for me, I would say try and think about the boundary of concern for the logic that you're writing, right? Like, if you could take what you're writing and break it up into like 50 different logical functions and then orchestrate those functions with conditions and flow at the top, then you've probably built something that can be broken apart efficiently with step functions. The other thing to really think about is, are you waiting for anything at any point in time, right? Because even with a 15-minute maximum execution time in Lambda, there are going to be processes that are going to exceed that 15 minutes. Even if it's only 3 minutes and you're not doing anything for 2.5 of those minutes, you're spending money while that function is executing. So anytime that you notice that you now have you've built a polling function inside of a Lambda, then start thinking step functions. Because you really want your Lambda code to be single purpose wherever possible, to execute as quickly as possible, and then to be done, right? So really your goal is 100 milliseconds of execution at the end of the day, so that you're breaking apart your logic into the smallest possible concerns that you can. It also then gives you flexibility to start recomposing those capabilities in different ways. So you build it all into one function, you're trapped within that function. But I would say the most critical element is realizing that you're starting to build either polling or orchestration logic into the function, and that's something that's probably best abstracted.
This workflow can also be implemented in simple workflow service.
So the question is, can this be implemented in a simple workflow service? Yes, but our guidance at this point would be look at step functions first.
I assume all the Lambdas here has to deploy at the same time, or it should be in the same package? Can it be
No, so the question is, do all these Lambdas have to be deployed together? And the answer, I think, goes back to your question a little bit, is no, right? So apply the microservice mentality a little bit here, right? When you build these things, you're specifying the ARN of the Lambda that's going to be invoked at that point in the workflow. But that Lambda function can be iterated on and deployed independent of the step function workflow.
So what are your thoughts on documenting this? Because you've had a few different visual representations. Sorry.
You've had a few different visual representations of workflows, for example, polling versus direct service integration. What are your thoughts on documentation?
So when you say documenting, the next developer in is going to understand what's going on?
Yeah, or maybe even a business user, a business person who might want to understand how the data is flowing and how it's being manipulated, that kind of stuff.
Within any of the architectures, or?
With this particular, sorry.
The step functions.
Yeah.
With the step functions?
Yeah, with the step functions, or even with the previous architecture, because they're similarly represented on the slide.
Yeah, I mean, the step functions are effectively a DAG, right? So they're sort of self-documenting in a way. I mean, you need to find a way to visually represent them in some fashion. You write them in JSON. If you look in the console, you actually see something that kind of looks like this. We will draw out what the DAG looks like for you visually. I think it kind of depends on what your standard format of communication is internally for this type of stuff, right? Is it like a wiki, like a Confluence type thing where you're keeping general business logic updated for people to understand? It's going to be on you to essentially extract the information in the format that people are used to consuming it, and then putting it in that format for them. For the developers, it's the actual underlying element is structured JSON, so it's in a way sort of self-documenting. Does that make sense?
Thanks.
Yep.
What will be the execution of this step function? Will it respond to the same event, not respond to the if I want to have an event with an object?
Yeah, so the question is what does step functions respond to? So step functions will respond to events. Off the top of my head, do you know what the list of events will respond to is? And okay, so some of the options for invoking a step function workflow are an SNS message, so you can subscribe it to a topic, a direct API call, like we talked about invoking Lambdas directly, or you can attach it to API Gateway. API Gateway, okay.
CloudWatch events.
And CloudWatch events. So a mental note on my part, spend way more time breaking out step functions next time. Or maybe build a step function talk. Yeah?
Are there limitations with using step?
Are there limitations with using step functions with Lambdas that are different AWS accounts or regions?
That is a good question. So can you invoke Lambda's cross-account through a step function workflow? I do not know the answer to that question off the top of my head. So let's talk about that afterwards. Cool. All right, so let's get into some of the best practices. as I mentioned, these are going to break down into a couple different categories. You know, despite Lambda being around for almost 5 years now, the rapid evolution of sort of serverless in general, I think always kind of leaves us in a position of these are the best practices that we're aware of, unless you know better ones. So this is going to be an evolving, evolving document or evolving body of work over time. But these are some of the things that at least I've seen directly with customers, or that we see consistently across all of our customers as they start building out. Right. So our goal here, I guess, is to be the happy ball, not the other balls. So one of the most common questions I get is, how do I test, right? So now I moved to a completely different paradigm. I don't know anything about this. I've taken my large application and broken it into all these small pieces. There's like weird interfaces to it. What do I do with this? So, the answer actually is that things don't really change that much from a philosophical perspective. The things that you want to think about here are making sure that you decouple your business logic from the actual handler of the Lambda function, right? So as you're building software, you should be able to test the components that you're building the same way you always would. So use the same frameworks that you're comfortable with for your unit testing. Your unit testing really shouldn't change because you should keep the invocation of the Lambda handler separate from the actual business logic that you're building. So use Jest or whatever you're comfortable with, the language that you're using to do your unit testing. You can also leverage frameworks and tools to help you with things like mocking in AWS services or events or service responses for that local unit testing. Some of the frameworks will actually spin up simulated resources for you, so you'll get like a virtual DynamoDB table, a virtual API gateway, some local serverless framework. They'll all give you the option to do local testing, but consider that to be essentially a convenience for yourself, right? Like that is an ability for you to iterate rapidly while you're developing locally and to keep your flow. As soon as you move out of that and get into integration testing and start moving up the stack into smoke testing and production testing, use real services for that. Don't use mock services or stub things for integration testing and anything beyond that. You cannot ensure that you get consistency between your fake services and the actual services out in the wild. So you can only take the sort of local testing paradigm so far. It's attractive at first because it kind of seems like you can build a completely production environment, AWS environment on your laptop, but it is not an appropriate testing environment for integration testing and above. So that I think is really the biggest call out that I would make there. From a deployment perspective, I sort of fortunately kept this section a little brief because I think next 2 weeks from now, you guys are going to really dive deep into CI/CD in the serverless world. But from what I've sort of uncovered working with my customers, again, the tools change a little bit, but the overriding philosophies stay more or less the same, right? So you're trying to move towards a sort of Git-based workflow. You want to build pipelines directly from your source all the way through to production. You want to automate as much as you can. And again, lean on frameworks and tooling to help you with that, right? Get things like traffic shifting, canary deployments, blue-green deployments, live monitoring of errors and automatic rollbacks. All those things are actually fairly easy to accomplish if you leverage the frameworks and tools that come out of the box in this environment. So you can get to a pretty good, pretty sophisticated, pretty mature state just by leaning on the things that are already built into the tooling for you. But the same sort of philosophies of CI/CD that you're used to in a traditional environment still apply here.
Very specific tips you could give for like tagging yourself part of the CI/CD flow
For
Lambda in particular, or in order to like get a better overview of like what services you use or like which team that is accountable for a specific setup on those.
Yeah, so the question is around tagging for, and is that for environment identification or?
Yes.
Okay.
Like just like attributing specific environments with specific
Right.
teams and specific.
Okay, so how do you attribute one thing to one person? So we have moved towards a pattern in general of recommending that you look at an account, like a unit of an account, as the granular unit of a workload. So even within a particular workload A, workload A dev, workload A test, workload A prod can all be individual accounts, right? There's no cost associated with that. It seems at first like there's complexity associated with that, but in reality, account management has become pretty straightforward at this point, using services like organizations to either create or manage the accounts and enforce policies on those accounts. And really, the only thing you're sort of dealing with from a user perspective is cross-account access, which is literally one component of the same ARN you are already providing in the first place, right? So while it seems like there's a little more complexity to it, the easiest answer for that is literally to break everything into their own account. Alternatively, you could look at combining some of those things into one account based on the team that you want to attribute it back to, right? So it's very easy, especially with serverless, where you're not incurring sort of running state costs, right? It becomes very, very cost effective to have all those different environments running at any time, or even to do that sort of GitOps model where like a developer has their own, they create a feature branch and they get an entirely separate environment for themselves to work on in a feature branch. Super, super cost effective inside of the serverless construct. So maybe you have like a sandbox environment where all those feature branches are, because you just sort of lump all those together from a cost perspective. But the actual workloads themselves go into their own accounts, and then maybe you run everything from dev plus one up in the same account, or you break them into different accounts. Does that help? Yeah. Okay. Something else I wanted to mention is Lambda layers. So the idea here is that you can provide effectively like a starting point, like a base layer of existing code for your Lambda function to run on top of. This is something that I could have used a couple of years ago when I was doing a lot of Lambda development. I built some really interesting grunt-based workflows at the time to ship shared libraries around between different functions before I deployed them. I had a source of truth, and then I needed that same functionality in a bunch of other different functions. And I was literally using grunt to copy code between different portions of the repository at the time. Not a good idea today. So you can leverage something like Lambda layers to basically provide shared dependencies, shared libraries to all the functions that are going to be running in your account. Right? So all you do is specify that layer as part of the Lambda function, and then the resources that are in that layer are available to you at a mount point inside of the file system of that Lambda. So really good way to separate the slow-moving stuff in a workload or in an environment from the fast-moving stuff. So the stuff that is consistent and shared and common across all the different resources, it doesn't change very often. Certain known good versions of things, even internally developed things, can go into those shared Lambda layers, and then you can build the faster-moving iterative stuff on top of that. So if you haven't played with Lambda layers, I highly recommend taking a look at it and sort of getting a sense of the capabilities there. Still in our DevOps category, I want to talk a little bit about observability, right? So another question we get is, well, okay, cool, now we've deployed everything serverlessly, how do I SSH into my Lambda function and see what's going on? You actually, I believe, can SSH into a Lambda function if you really try hard. But again, not a pattern that we're going to be using anymore, right? So how do we understand at a high level of detail and granularity what's actually happening between our microservices? X-Ray is a service to look at for this. Really, really underappreciated capability. It is super simple to get started with, and it'll give you really, really nice graphs of your microservice and the different dependencies that you can see on the right here. The circles here represent error rates or latency, that type of stuff, right? So by literally including like 1 or 2 lines of code at the base layer, this is an example here for Node, you get tracing, distributed tracing across multiple AWS services and between functions, and metrics on latency and errors and things like that between all those functions. So it makes it very, very easy to dive in and see where in that microservice iceberg you may be incurring the errors or latency that you're having trouble tracking down. You get really nice waterfall graphs like this that give you perspective on Lambda startup time, and then over the lifecycle data first request, where that request is waiting on downstream services.
Just a quick question. Do you have to call X-ray on all your Lambdas, or do you just call it at the head and it's inherited across them? Or?
So if you have multiple lambdas involved, you will need the X-ray. You'll need to instantiate X-ray. I think in all of them, if you want again continued like visibility downstream.
It depends. There's X-ray all the time that is enabled. So X-ray is enabled all the time. In Lambda, you just have to click a checkbox, but that's extremely high level. If you want down level like it is right now at just S3 and then the call to S3 want this to be X-ray, you see the SDK is wrapped. So AWS X-ray captured as AWS, that wraps the SDK so that every calls you make to the SDK are going to be there. So then every Lambda that you want this D needs to have that.
Okay. Oh, perfect.
Thank you. Okay, so distributed tracing, right, through X-ray. And then let's go back just to some of our like core principles, right? Metrics. So all the services in AWS constantly generate metrics. What's happening? What is the latency? What is the request volume? What is the error rate? So make sure that you get comfortable with those and understand, which ones you want to pay attention to inside of your workload. Which ones do you want to build alerts and alarms on? We also have some automatically generated dashboards now in CloudWatch based on the service that are a good starting point. So check those out. But at some point, you will want to become familiar with CloudWatch service and the different metrics that the different services generate, because that is your visibility into how your application is performing and behaving. So whatever the service might be, whether it's Lambda and you're looking at the number of errors that are occurring, you can do math in these metrics as well in dashboards. You can do sort of percentage error rates, things like that. All these things are going to be things you want to get familiar with. Logging at every level, right? So whether it's the API logs from API Gateway, whether it's logs coming out of your application, these are all things that you can write into CloudWatch, highly available, durable event storage, like log storage for you. And you can use those to do debugging. You can use CloudWatch, the search function in CloudWatch logs. You can export those logs in something like Elasticsearch if you want to get a little bit more involved and start building Kibana dashboards over top of them. Something else I wanted to call out here, under log pivots, there's something called metric filters, which are really, really interesting. So on the previous screen, we were talking about metrics, right? So there's pre-generated metrics for you around things like invocation rate. You can also generate your own custom metrics. So if there are things about your application behavior that you want to track, you can calculate those in the application and post them as custom metrics in CloudWatch and put them into a dashboard with everything else. You can also generate the same metrics potentially out of your logs. So if you're already logging, if that information is already being written down in your sort of typical, row-based log format, you can build metric filters over those logs that will produce the same metric values without having to do that out of the application itself. So there's two different sort of approaches you can look at there in terms of custom application metrics that are important to you. Either post them directly out of the application or calculate them based on the data that you're writing into your logs already. The second option is going to be significantly cheaper as well as no obligation to build that logic into your application. Anytime you get into using SQS, something else that you absolutely need to start thinking about is dead letter queues. This is an opportunity for you to take messages that cannot be processed, that continuously get put back into the queue, and stick them somewhere so that they don't remain in the queue indefinitely. Right? So if there's something about the content of the message that is either malformed, sort of poison pill style, don't allow those messages just to be constantly recycled back into the queue or thrown out, because there is a retry limit as well in messages. Make sure that they land in the dead letter queue, and then treat that dead letter queue as another monitorable element of your infrastructure, right? So even sort of like a metric of we have a single message in our dead letter queue, we need to raise a non-critical ops alert so that we can understand what's happening. Is there an edge case that we didn't consider when we were building this, or is there something wrong with the latest deployment, or is there something wrong with the infrastructure? So these are an important fail-safe when you're building sort of these distributed processes between services, so make sure you leverage them. All right, everyone's favorite topic, Lambda performance. Quick recap on the things that you have control over, the things that you don't. Right. So we talked earlier about shared responsibility. In this case, this is the lifecycle of a Lambda function. So if it's never been run before, the first thing that happens is the service goes out and grabs the code package that you uploaded, right? So the zip file, all the dependencies, and the actual code. Then we go find an execution environment for you, right? We allocate compute for you. We download that code, we put it into that environment, we turn up the runtime, and then we execute your function for you. So on the left-hand side of the screen are the things that we worry about, right? And over time, those improve. On the right-hand side are the things that you worry about. And these are the things that you have the ability to influence. So let's talk about what some of those things are. So if you look at sort of, this is a, I guess, real code, sort of. If you look at different areas of potential Lambda function here, right? How do we reason about where we want to make improvements? So some of the things to think about, things like database connections, dependencies, common libraries that you can use throughout the entire thing are things that should be loaded right up at the top. I'll back up again so you can actually see here. The 6th line down is your entry point into your function, right? That's your handler. That, when the function gets called repeatedly over and over and over again, that is the entry point where the event payload is delivered, okay? So everything that happens before that handler is executed when that environment is created the first time. That environment is then potentially reused, and that handler is re-executed for the 2nd, 3rd, 4th, 5th invocation. So this is a really important concept to understand. So anything sort of long-lived like a database connection, anything like libraries that are going to be used consistently throughout the function should happen before the handler, because that means it's going to happen when the environment is instantiated, and it's not going to have to be re-executed every time that environment is called upon to re-execute the handler. So take advantage of that execution context to improve the performance of your function by loading those one-time needs there so that they're already available the next time around. This is a little bit of an interesting concept because we tell people to think about Lambda functions as being stateless, right? So don't assume state in a Lambda function because we cannot guarantee that you're going to get the same function the second time you send a request. At the same time, from a performance perspective, understand that there is execution context reuse and leverage that to your advantage from a performance perspective only, right? Not from an assumption of state perspective. Other things to think about, down in your business logic, if you instantiate something like a database connection up at the top, be prepared for it not to be there anymore at some point further down in the function, right? You still need to validate your connection is still good, and you may need to reconnect down below. So don't, just assume that everything is perfect because you did it once up at the top. Still build in the appropriate checks and error handling that you need to, or reconnection you need to. But know from a performance perspective that as long as that connection is still valid, you don't need to recreate it every single time. A couple other things you can think about, minimizing package size is always going to improve the performance of the function. Think about sort of the equivalent of tree shaking, or if you're using like the AWS SDK, for example, do you need to load the entire AWS SDK into your function if the only thing you're going to do in there is call DynamoDB, right? You don't. So scope your require statement down to the actual component of the SDK that you're going to use as opposed to the entire AWS SDK, just as one particular example. The other thing we talked about earlier in terms of testing, right? Like separating the business logic out from the actual handler is somewhat showcased here. So the core logic of the function is down at the bottom in the green and yellow, and the handler itself is very, very simple. Like the question about self-document or about documentation earlier, like when you go and look at a Lambda function for the first time, it should be pretty clear to you what the conditions and what you expect the path or behavior in that Lambda function to be from the handler. The handler should be short and it should definitely fit, on one screen, and then all of the logic that you're relying on should be in its own functions further down inside the Lambda functions. Last thing I would say here is be very, very cautious about any sort of opportunity for recursive code. You will very quickly consume a large amount of compute, which is not what you want to do. So just be conscious of any sort of potential loop or recursion that you're building into your function as well. If you find that you have initiated some sort of long-running recursive process in Lambda, your escape hatch there is to set the concurrency on that function to 0, and that will effectively kill the function. Another thing that we should mention that came up earlier is in that Lambda instantiation process. So back here for a second. On the left-hand side of that, under Start New Execution Environment, is the creation and attachment of the network interface if you need VPC access, right? So this is a great example of why you rely on us to do some things and why you do some things. So last week we announced that we are moving forward to something we call VPC to VPC NAT. It's going to change the way that we use ENIs inside of Lambda. It's in the process of rolling out at this point right now. We expect, I think, so about 10 weeks or so to roll out across the entire platform. So at some point you will notice that your ENIs are attached to your Lambda functions very, very quickly. So we've gone, potentially from seconds, multiple seconds on a cold start with VPC access, back down to an extremely small number. So this is a great example of us working on the platform on your behalf while you continue to focus on the things that we talked about for optimization inside your actual function itself. A couple of the things around cold start in general. There are some strategies out there to manage it. Things like CloudWatch events to keep Lambda functions warm. If that is useful to you in your environment, then it's something you can look at. You need to think really hard about the actual impact of the occasional cold start on your workload and whether it's tolerable or not. How rapidly does your workload scale? How infrequently does it get access to those types of things? But focus really on the optimizations that you can make inside the function. One other thing I guess I would also bring up, we talked about the fact that you're building distributed systems, whether you like it or not. That means there's a lot of network calls, right? So something that we've encountered with customers and something that Frank encountered recently as well is that occasionally networks do strange things, right? So inside of a Lambda function, your goal again is to have that function run for the absolute minimum amount of time possible. Things like HTTP clients or libraries inside of those functions you're loading have defaults. Those defaults can be things like 60-second HTTP timeouts. If you're accessing a service like Dynamo, where you can reasonably expect that service will respond to you within milliseconds, you can set your timeout to something like 1 or 2 seconds comfortably, right? Because in those edge cases where the network has failed you, don't wait the 60 seconds to retry. The SDK will retry automatically on your behalf. If you set that timeout to say 1 second, in those edge cases where you have network issues, it's just going to retry right away, and your user will see no impact. If you allow things like 60-second HTTP timeouts to remain, you will see user impact for those stuff. So keep that in mind as well. One other thing that you can do in terms of performance is think about how far you want to turn the resource knob. So Lambda functions, you apply one value from a resource perspective, right? You set a memory level. Understand that when you set that memory level, that also influences the amount of CPU and network capability that function is allocated. So something to try and figure out is what is the optimal amount of allocation to my function? Does my function scale linearly? If it does, then it doesn't really matter where you set it, unless you have performance considerations for your user, right? If you want really low latency, crank the knob all the way to the maximum. Because it's linear, the execution time will drop accordingly, and your actual cost to execute the function will be the same. If your function does not scale linearly, you want to find the sweet spot based on your business constraints. So is it cost, is it performance? You need to decide that. What's it? How do you do this? How do you actually figure out what the right one is? You have to test it. Something I would recommend checking out is a tool generated by, I believe, one of our SAs from the US. So Alex, yeah. So this is in the Serverless application repository, so you can actually find it directly through the console if you want to, or if you want to better understand how it works, go check out his GitHub repo. You can search for AWS Lambda Power Tuning. This is a step function workflow that will test your function at all the different settings of the resource configuration knob, right, from small to large, and will recommend to you the most performant option. So there's an automated way to do this, or you can tinker with it yourself. Multi-threading, something to consider, right? So again, on that knob from 128 megabytes all the way up to 3 and change gigabytes, at a certain threshold, which is 1.8 gigabytes, you get access to more than one CPU core. So if you're using multi-threading and you're running a Lambda function at a resource level below that, you're not getting any benefit. So keep that in mind if you're trying to do something involving parallelism inside the workload itself. Okay, security. There was a really good talk on serverless security a few months back, I think, by Andrew Brown from ExamPro. I would highly recommend checking that out. He goes very, very deep into a bunch of different use cases around security. I wanted to stress a couple key components that I see customers sort of struggle with on a regular basis. The first one is how do we pass configuration to our Lambda functions? So you have the option of setting environment variables for your Lambda functions when you create them. You should use these environment variables to do things like tell it what stage it's in, right? Is this a dev function, a test function? What team is this being run for, that sort of stuff, if there is any sort of impact on the configuration of that function based on that information. These can be encrypted using KMS. If you're in an environment where you're trying to achieve ubiquitous encryption and you want to check that box by encrypting your environment variables in the service, go ahead and do that. But I would strongly encourage you not to put secrets in your environment variables. Okay? So it used to be a significantly better alternative than putting your secrets in your GitHub repo. But at this point in time, especially with the improvements and accessibility of logging, I would strongly discourage you from including your secrets in your environment variables. Environment variables have a tendency to be exposed where you do not expect them to be exposed, and that highly confidential information can be at risk. Okay? So use environment variables for configuration-related challenges, also possibly for like a path to your secret in another service. So when we get to the actual secret side of the house, leverage something to store the secrets securely, like parameter store, secrets manager, HashiCorp Vault, whatever tool that you're comfortable with. Put your secrets into a purpose-built tool for that. Do not put your secrets directly inside your environment variables. So use something like parameter store. This is an example of it on the right. So we thought about how we build our Lambda functions, doing helper functions. So get parameters being a helper function, and then executing those helper functions in our business logic. Reach out on execution, get the secrets that you need, and use them as opposed to storing them consistently in your environment variables. These services are purpose-built for this, so they bring you all kinds of benefits. I'm not going to read them all, but they're basically benefits based around security compliance, logging, audit, encryption, and keeping those secrets out of places where they have a tendency to leak. Lastly, really understand on the security side, really understand the difference between the permissions that you're granting to invoke your Lambda function and the permissions that you're giving your Lambda function while it's executing, So there's two separate areas of concern when you're talking about least privilege with serverless. One is what is allowed to invoke this Lambda function, and then the second is what is this Lambda function allowed to do. So if you're building with tools or frameworks like the CDK or with serverless, they can be a little bit more prescriptive for you on how to do this properly. If you add a resource like a DynamoDB table, they will be good at scoping the access from the Lambda function strictly to that DynamoDB table. But don't assume this stuff and don't take it for granted. Review policies that get created and make sure that you are not allowing access to service.star from a Lambda function that does not need that type of access. You should be scoping down the resources that it has in terms of execution directly to the tables or to the S3 buckets or to the relational database, data API if you're using or serverless that it needs, and making sure that you're not using sort of the star model in any of your permissioning. Okay. I think that is the end of the tips. So I wanted to leave you with a couple of resources as well that I find really helpful. One is our serverless portal. So this will take you to reference architectures, it'll take you to TED Talks and videos online, it'll take you to white papers. If you are getting really serious about this and running these things in production, we have this concept of the well-architected framework in AWS. So this is very prescriptive advice around security, operations, cost management, performance, and reliability. There is a serverless lens for the well-architected framework now. So there's a way to take all the principles that apply across those 5 pillars and apply them specifically to a serverless workload. So check out the serverless lens in the well-architected framework if you're doing anything in production, especially, and use this portal as a jumping off point to all kinds of different resources to you learning about serverless in general inside of AWS. And it was already mentioned once today, I think, but strongly endorse the serverless stack as well. This is now, sort of the Bible. A lot of positive commentary on this I see across the board from both customers and colleagues. So, use this as a compendium of knowledge to help educate yourself about patterns and practices and approaches that you can take inside of your serverless workloads. So that's it for me. Thank you very much for your time. I hope, again, that you saw a pattern that you hadn't considered serverless as an option for before tonight. I'm happy to take some questions. I'm very glad to have my friend John with me here as well too. So between the two of us, I'm presuming we can tackle most of your questions, and then certainly happy to dive deeper into things and take some stuff offline if we need to as well. Please reach out and let us know what you're building. We're always really interested in understanding how people are using these things. Let us know where you're finding rough edges so that we have that feedback. And yeah, stay in touch and we're ready for questions, I think. Thank you.
We all know that cloud formation template that has a 200 resource limit. So what's your suggestion for those who want to build an enterprise scale or large scale serverless applications?
So I think the question is understanding that there's a template size limit in cloud formation. How do you build enterprise size applications?
Yeah, I would like to share some skills that our team is using. Firstly, we separate the declaration of some DynamoDB tables as well as repub table call from distribution outside the Lambda function template. So another way that we are using is to use grid pubbing of serverless framework. It's called serverless list stats. That kind of like aggregates the Lambda functions, the item roles, and the API gateway endpoint into a nested cloud formation stack. That's the well approach into the 200 Lambda function limit. So what's your suggestion for us to?
Yes, I mean, I think you're already doing some of the things that we would strongly encourage, right? So thinking about breaking your infrastructure into like discrete components, leveraging the ability to import and export values between stacks, that type of stuff, right? If you are still finding that you're reaching a point where you are constrained by template size, I think that would be a case where you have to really sit down and look at the actual, workload that you're working on, and think about other strategies in terms of keeping those things in, not bite size, but reasonable size chunks in the way that you can sort of bring them together again, either whether it's through imports and exports or nested stacks or that sort of stuff, right? There are going to be limits within the template size that are hard limits. So I haven't really discovered a customer yet that hasn't been able to find a pattern that works for them in that process. So if you feel like you are at a hard, stop based on that particular constraint, then I think we would just want to sit down and look at it, directly and figure something out for you. I don't think there are any sort of general guidelines beyond, what you're already talking about that I can give you.
Okay. Thank you.
Thank you, great presentation. I actually have two questions. First, can you elaborate more on serverless and VPC? Because, for example, Kinesis Firefox cannot push data to Elasticsearch, which is inside VPC. Lambda, when you put Lambda in the private subnet, you also might have some issues. So can you elaborate maybe some patterns or anti-patterns which your customers found? And second question, you said you work with startups. Maybe can you say a couple of words like who can apply, who is eligible, how can you help?
Sure. Okay. So on the first one, I think our general guidance around VPC and Lambda is don't use VPCs unless you absolutely have to, right? So start with no VPC, and then as you start to build your workload, if you have resources that are inside of your VPC that are private and you need access to, then you have no choice, right? So then you have to start incorporating that. Typically it's things like RDS instances that came up earlier. Can you help me better understand like what the question is there in terms of working around the constraints of that?
You partially answered it. When you put Lambda in VPC, you can put it in private subnet, you can put it in public subnet.
Yeah.
And if your private subnet has 256 IPs, then you may have scalability problem.
Right. Okay. So VPC to VPC NAT is going to help address the IP space exhaustion challenge. It's not just a performance improvement in terms of the launch time of the Lambdas. It's also an improvement in the way we manage the ENIs and the IP consumption inside of the VPC. So you'll see some improvements there already. What else? Anything spring to mind?
The other thing I will say is, like when we say you put your Lambda function in a private VPC, the container does not run in your VPC, period. The container is outside and it's just an ENI that is now attached to your VPC, that is now shared with the container that is inside of our VPC, which you don't see, you don't manage that one. So you still access Lambda from the outside. You still do an API call to Lambda, the service, to your function from the outside. So like a Kinesis firehose is accessed from the outside, same idea as your Lambda function. So all the problems around Lambda inside the VPC was around the cold start, so that's being fixed, and the IP exhaustion inside the VPC, which again, that's being fixed with the NAT. So yeah, there's what has been posted in the blog post does go in detail on our hyperplane, and then it goes to a reinvent video of we explain the hyperplane, what we're doing with networking behind it. Thank you.
Yeah, I mean, I guess the only thing I would add there is just be conscious of that. If you are using, Lambda with VPC attachment, to John's point, right, is that ENI that is in the private subnet inside of your account. Just understand that you need to just make sure you do things like establish NAT gateways, they need public internet access, that sort of stuff, right? Just some sort of traditional patterns that are going to apply. I think maybe, I would say, look at the frameworks that you're choosing to use to model this stuff out and see if they provide any out-of-the-box patterns for that type of stuff, and they should incorporate those best practices in them, that kind of thing. Your second question about startups. So just quickly on that front. So I work on the startups team. We're a global team that is effectively mandated to help startups in the ecosystem in any way we can, right? So one of the primary ways that we do that is through our Activate program. Activate is a program that gives startups benefits like platform credits, like access to resources that they may have a little bit more challenge getting direct access to normally. We do things that are non-technical with them, like help them with fundraising, help them with pitch deck review, help them with customer acquisition strategies, introductions, whether they be to customers or to potential sources of financing. So everyone on the team comes from a startup background. We're all ex-founders. We've all been in that role before and understand very clearly like what the challenges are. So that is sort of the mandate of the team. How do you get involved with us? The easiest way is to be in one of our partner programs. So I mentioned that I work with like accelerators and incubators and VCs and things like that. That's the sort of primary path of access, right? So if you're in like the DMZ, or you're in Mars, or you're in like a program like Techstars, for example, right? You're a little further down the road, then you already have access to those benefits. If you are not in one of those programs, if you're bootstrapping, which is near and dear to my heart because that's what I always did. If you have traction, like if you are sort of beyond the my buddy and I have an idea phase, and you actually have some sort of demonstrated traction and credibility, we can still help you, right? So it's just it's not an automatic thing, but you reach out to the team and then we help you sort of get through the process and become part of the Activate program. So those are really the two different approaches to it, right? So if you're not in a program today, I would say definitely look around the community and find a program that might be a good fit for you. When I was doing this, I don't even want to say how long ago it was. The ecosystem and the community were not what they are today. There is so much help out there available to startups in Toronto and Montreal and Ottawa and Waterloo right now that you should be taking advantage of if that's what you're thinking about, right? There are very low barriers to entry to a lot of the incubation programs. Like, you can show up with an idea on a napkin and get started, right? And they'll help you with all the different things that you're probably not thinking about in terms of getting that startup from idea phase to some sort of like MVP. And those programs are typically part of Activate as well, so then you get benefits from us. But really, almost more importantly, is you get embedded in the startup community and you start getting access to other founders that are at the same stage that you're at or that are a couple steps ahead of you and giving advice back, right? There's a whole tight-knit community of people that are focused on this. Another amazing program is Founders Institute. So it runs on a sort of cyclical basis as well, fi.ca, I believe, fi.com or fi.ca. Check that out. That's an early stage program. You don't need anything other than an idea to show up the first day, right? So there are a ton of these resources out there in the community. If you want help trying to find the right one, I'm happy to try and help you with that as well. Just reach out directly. But there are a lot of different entry points that you can get in, and then you suddenly have access to all these different resources that you had no idea were there.
Thank you.
So Lambda is being triggered by SQS, right? Messages are usually delivered in batches of 10. You failed to process one message, all 10 get retried. Is there going to be any more granular control over it, or?
So I would rephrase it a little bit. SQS is being pulled by Lambda, right? So not Lambda being invoked by SQS. I mean, it's semantic, but in that case, it is a little bit important.
But eventually, the Lambda is triggered by putting the message in SQS.
Yeah. So I think to try and get to the use case though, what removes the messages from the queue and causes so the message doesn't actually come out of the queue and get put back. The message gets essentially hidden in the queue, right? It gets marked as being processed. When your function returns a 200, the messages are wiped from the queue. If your function returns an error, then the messages are unhidden. So you can potentially control like that behavior inside of the actual Lambda function, right? As opposed to having uncaptured errors or purposely bubbling back up in error. You could use something like a secondary queue or a dead letter queue or something like that to take that one poison pill message out of the process and then 200 back the original ones. I think you're asking like, are we going to do that?
We're already doing that kind of stuff. I'm just wondering if AWS is going to give us more granular control.
Right.
Or something.
I don't have anything I can share with you today, but I would just sort of point to our sort of our habit of like iteratively improving these things based on feedback. So if that is something that you find to be a pain point, if you don't know who your account manager and solution architect are, find out. I can help you with that. And at AWS?
No.
Okay, so you have an AWS solution architect if you're working on the platform. You do, trust me. So I can help you find them. And one of the functions of the SAs is to collect that feedback and surface it internally, right? So the more people we have telling us that this is a particular piece of boilerplate that I really wish I didn't have to write, the faster that you will likely see that as something that is incorporated in the service. Cool. Thanks.
One more.
You gave a presentation on AppMesh, and somehow in my world, AppMesh is related to Lambda, serverless services. Does AppMesh fit into this world, or it's mostly for services and containers?
So the vision for AppMesh is that it is a pan service service mesh, right? Over time, so things like Istio are very specific to a orchestration system and containers. So do you know off the top of your head whether there's like Lambda support in AppMesh today? Yeah, I mean, I would say it's not a first-class citizen today, but I would expect it to be a first-class citizen at some point. Yeah.
All these patterns our one-to-one transformation. So if you are going to right, you need this.
Yeah. Yeah. Was there a question back there? No?
Yeah, so I have a question about connection pooling. So when you allow Lambda functions, let's say you have like middle request coming in, you'll spin up a lot of Lambdas and the all connect database. So like, what's the best practice if you're not using a serverless database?
Yeah, so think again about like, in a way, sort of think about the execution context, like rationalize that to the VM in the old world, right? So if you're going to be scaling out a bunch of VMs, how do you manage the connections and the pooling requirements across all those VMs versus how are you going to, if you're invoking a connection at the top of your Lambda function, right? And that single Lambda function is going to get a lot of reuse, so you're going to be reusing that single connection or connections in that execution context. But as you go really, really wide with Lambda, potentially, right? Like into the tens of thousands of executions per minute or per second. That is really practically no different than if you were scaling out a bunch of VMs to the same level horizontally. So the same requirements or strategies around managing connections and connection pools and ensuring that the downstream database service can support that level of connection applies equally the same, I would
The thing
say.
is, I don't have control for it because I can control how many it spins up, right?
Yeah.
Okay, so that was the problem I had, right? Like, so I put a connection pooling in between the database and the Lambdas, and that solved it temporarily. I don't know if that's the best practice.
We're using something like PG bounce or
Yeah.
PG pool or something. Okay. Yeah. I mean, if you find that the reactivity of the system is such that it gets out of like the constraints that you expect in certain periods of time, then that's a strategy that you're gonna have to employ in the short term, I think. I don't have anything to add to that.
So there's no best practice answer on what to do.
What you're doing today is our guidance at this point.
Okay, and then you said that sometimes the connection may drop all of a sudden, right? So, like I said, you spun up let's say you spun up 10 Lambdas, and you're constantly getting traffic in. All of a sudden, some of them might just lose traffic.
It's a bit like you may choose to do that, right? So like if you're using Aurora Serverless, for example, Aurora Serverless in a dev test environment can scale to 0. Well, I mean in any environment, but I wouldn't do that as a dev test. It can scale to 0 in dev test, but the way it decides to scale to 0 is a lack of connections, not a lack of queries. So if you choose in your library for database access to release idle connections after a certain period of time, you may get down to 0 connections at some point, right? Or there may be a failure. So what I was talking about there was just not assuming that a database connection that was instantiated in the global scope survived 100% of the time. It's really like an edge case situation as opposed to like a sort of standard problem you have to deal with day to day.
Okay, and then the thing I noticed was that every time I deploy a Lambda up, it takes some time. It's not fast, right? So like, what's your best practice to cut it down?
The speed from like you pushing from your laptop to deployment.
Like I would have like 100 Lambdas. It would take me like maybe 2 hours. So usually like it's just like it was well.
So you're deploying 100 Lambda functions simultaneously.
No, like what? Like I think you're not going to deploy one at a time, right? Like you can't. You could open like 10 terminals or whatever, like deploy 10 at a time, right? But like
Right.
just one at a time. Is there a depend on user speed? And, like,
I mean, so like I said, effectively you're uploading a package, right? That package is going to affect it at the end of the day land in S3. And then that package needs to be deployed on the next invocation to the new execution environment. So it sounds like you're sort of talking about a serial process in your terminal of continuously updating like a whole bunch of different functions. I would be curious to understand the use case where like hundreds of functions are changing
no,
simultaneously.
for example, like you deploy the dev as you actually go off. But when you deploy production, then you deploy all of the ones. As an example.
Right. So I mean, I would maybe challenge that pattern. Like I think if you're breaking them apart, ideally you're hopefully operating in a means where you're treating all of them as individual concerns, right? So you shouldn't necessarily be like working in isolation for a month across 100 different Lambda functions and then deploying them into production at exactly the same time. I mean, it might be a constraint of a workload. They're all so dependent on each other that that's the case, but I don't see that very often. I never see that actually. So
the other thing is if you're using CloudFormation around it, so CloudFormation will parallelize all of that. So it will do the deployment of every single one of the functions at the same time. That's what CloudFormation is supposed to do. The other thing is you can call the APIs from multi-thread your terminal or your push that you're trying to do, and then call the API. We probably have an upper limit on doing a deployment of a function, but I don't think it's not going to be 5. It's probably going to be in hundreds. So you sending 100 API call concurrently, like by multi-threading your deployment instead of doing a for loop of going across all of it. But if you're using CloudFormation, it is supposed to parallelize this unless you made one Lambda function dependent on the other Lambda function. If you did that,
I wasn't releasing CloudFormation, like
you were.
No, I weren't.
Okay, and if you're not, that's okay too. But then just make sure that you parallelize that deployment so that it doesn't do serialization. Because on the Lambda side, deploying 1,000 functions exactly at the same time, it's okay. Like it's just like 1,000 function runs to us. We just redeploy the container right back.
Okay.
Yeah, I think I'd be interested in like if it's really a 2-hour process for you to get those things to the door. I'd be interested in seeing how you're doing that. I think.
Part of it is
Well, no, like I have all that, so like I just wrote asterisk to like deploy them one after the other.
Right,
Like,
okay,
so
yeah.
parallelize, right?
Yeah, so I would, yeah, I mean.
come to the CI/CD talk.
Yeah. So yes, I would say long term, like pursue a more abstracted approach to this. But in the short term, if you need something, like if you're running it on your CLI and you want to make this faster tomorrow, rather than doing it in Bash, I would consider like just rewriting it in Node and using async or something like that to batch them out, like 20 at a time or something like that.
Okay, and then for like best practice, do you just use Angular server? Because I really hate serverless server. And like it was really bad when I did it. I don't know about now, but like it will waste so much time. If I end up using small, let's just deploy the Lambda. So is there a best practice in Amazon, or do you just use your basic one? It's what you're.
I mean, I think more important than like choosing one service that is best is just saying whatever service you choose, know it well, right? So know that it works for you, know the ways that it introduces friction. Like whatever your favorite serverless management tool is, you should be able to tell me what you don't like about it or the things it doesn't do well as well as the things it does. We would strongly recommend looking at something like either SAM, or if you want to go one abstraction layer up, look at something like CDK. A lot of customers super happy with serverless. It's evolved quickly over time as well. So it's one of those things where you played with it like a year ago and it was frustrating to you.
Used in production, and like for a long time it was random stuff.
Okay. I mean, I think it's just, I don't think there's a best framework, but we would generally say start with something like SAM or CDK. But again, I think, they're tools, right? So you need a tool that gets the job done for you based on the way you use it. So find the tool that works for you and then become an expert in it. And those are the two most important pieces.
Okay. 2 more questions. So one is, I had a scenario where like I was running bcrypt on the Lambda function to like cache patterns, and it would take 20 seconds for it to like respond back, and like I never found a way around it.
Something I didn't mention actually in the resource slide was another edge case that we now found, bubbling up repeatedly across customers. There's a reasonably robust conversation about this on serverless Twitter not too long ago. Some of things like cryptographic operations inside of a Lambda function are going to require a minimum amount of CPU, right? So I'm not sure if you experimented with it or not, but sometimes the difference between turning the knob, from like 128 to like just over, like the 1024 will take an execution of anything involving, cryptographic functions or libraries from like 15 to 20 seconds down to like sub 1 second. So there's a non-linear relationship again between the performance if you're using a library like that and the amount of resource that you're applying to the function. So there may be a tipping point somewhere where you see like a order of magnitude reduction in execution time by increasing the resource.
I think I increased it 512. It still wasn't good enough. So I don't
So it'll go up to over 3 gigs, right? So
that's kind of ridiculous. It's like, I have to pay a higher rate because it can't be. Bcrypt is very standard, like it's.
Yeah, but cryptography is like non-trivial, right? So if you're dropping the execution time from 20 seconds to 100 milliseconds, and you're turning the knob from 500 to 3 gigs, you're actually benefiting substantially, right? At the end of the day, because there's 2 sides to this. There's the amount of resources you apply to it and the length of time the function runs. So the optimization may, be surprising actually with the higher amount of resources applied to it. I would at least try it, right? Like throw one execution at it and see what happens.
Okay. And then the last question is about like I've been configuring API gateway like manually because when I was using serverless, it was really painful to do. It wasn't doing what I wanted to do. So like, what is your suggested way to configure API gateway, automatically? Like,
So what do you mean by configure? Like,
you set up when you're passing the payload, how it should process payload, you should turn the principal ID and this stuff, and then configuring the output, the status code and stuff, and having all the authorizers, all that stuff.
Most of the customers that I see using it don't have a lot of complex requirements there. So the out of the box, the one that
I tried all the boxes.
Yeah, they get it from serverless or SAM or something works for them. If you really want to get prescriptive with the API gateway side of it, I would look at using Swagger to define it as opposed to defining it inside of one of the existing serverless frameworks.
So it defines Swagger and upload it, and it would just
Yeah. So you can in almost all the frameworks choose to use the Swagger definition as opposed to speccing out the API in the YAML or something like that. There are a couple of properties in the Swagger that you'll have to add for API gateway, but that's another approach if you want to get really granular with the way the API layer works.
Any other questions?
Is there any more pizza left? No? Okay. Thanks again, guys, for coming out.